Number 12, just like I did with number 11, I'm going to write the inverse up here just for the sake of space. But what I've got it to the 1/3 power, which is the same thing. That's the cube root of x minus 7. So I'm going to switch the x and the y. So x equals y minus 7 to the 1/3. I need to cube both sides to get rid of that 1/3, right? So I have x cubed equals y minus 7, and then I add 7 to both sides. And y is the same thing as f of negative 1x or g of x. All right, so now f of g of x is f of x cubed plus 7. And when I plug this in, I get x cubed plus 7 minus 7 to the 1/3. So going in parentheses first, the sevens cancel each other. Then we got x to the 3rd to the 1/3, which equals x. And finally, g of f of x, this is g of f of x, x minus 7 to the 1/3. And we take our g, boy, I got confused there for a second. Okay, x minus 7 to the 1/3 cubed, okay, plus 7. That gives us x minus 7 plus 7, because this cube undoes this, right? That undoes that, so I'm left with just x minus 7 plus 7 gives me x. All right, moving on to the next page. Graph the function and state the domain, range, and transformations. Ooh, I forgot to do the transformations on the key. I apologize for that. Okay, so what we've got here is what I did, and if you have the key, hopefully you saw that I did this. I did a table for each one. So for example, for this one, I got -5, -2, -3, -1.8, -1, -1.6, 0, -1.4, 2, -1. I jumped around a little bit, and then 4 is 1. So, and now I plot the points, so -5, 1, 2, 3, 4, 5, 1, 2. -3, 1.8. So this comes up very, very gradually until 2, -1. And we have 3, 0, 4, 1. Now I notice that it's a cube root. So it's not going to go like this. Remember that a cube root looks like that. All right, so this is going to come up. This is going to come up like that, and it's going to level itself off right here. Okay, so my domain, if I'm looking at the graph, my domain is where I see the x values that are there. I know that doesn't really make sense. I'm not sure how else to say that. But basically, I have all x values, okay? I can see it in the graph. It doesn't stop anywhere. There's nothing missing, so it's all real numbers, okay? My range is going to do the same thing. I'm going to get everything from the very most to the very least. Okay, so my range is also here. My transformation, okay, I'm going down, well, it looks like I'm going down 3, but because it's still under the radical, I'm moving to the right 3. So this actually started here, and it moved to the right 3. So right 3 units. Okay, Shoot, I'm kind of mad at myself now that I forgot that. Oh well. Okay, number 14. Again, I made a table here, and I picked values of x that I knew would give me whole numbers. So for example, I've got a square here, a square root. I know I can take the square root of 1 and it'll come out even. I can take the square root of 4. I can take the square root of 0. Sorry, now it's kind of out of order. And I can take the square root of 9. So if I take the square root of 1, that's 1 minus 1 is 0. Take the square root of 4, that's 2. 2 minus 1 is 1. If I take 0, this is negative 1. And 3, right, the square root of 9 is 3. Minus 1 is 2. So when I graph these, I have 1, 0, 4, 1, 2, 3, 4, 1. 0, negative 1. 9 is kind of out here. So this is going to shoot up like this. Now, when we're looking at the domain and range, again, look, there are no values of x over here. There aren't any. So I know that my values of x start at 0 and get bigger because there's nothing over here, and the graph shows that. So my domain is x is greater than or equal to 0. Now my range goes this way. So I'm looking at this and I have negative 2 and there's nothing below that. So my range is y is greater than or equal to negative 2. I'm sorry, not negative 2, negative 1. So y is greater than or equal to negative 1. And the transformation is 1 unit down. Or shifted, I should say shifted. I should say shifted over here too, or okay, so shifted 1 unit down. It's supposed to be up here, but it came down. All right, let me see where I am at with time. Okay, so we will go on with number 15 in the next video.